Hello students, welcome you all to the video lecture on 8086. Today we are going to discuss about 16-bit addition along with the carry. So generally whenever we are going to add two 16-bit data, for example 1, 2, 3, 4, 5, 4, 2, 1. So each bit, whenever I write in the binary, it will take 4 digits. For example, it is 4 means it is nothing but 0100. 3 means it is 0011. 2 means it is 0010. 1 means it is 0001. So totally 1, 2, 3, 4 means it is 16-bit data. Similarly, 5421 is another 16-bit data. So these two 16-bit data we are going to add and we are going to store the result. So if it is a number, again it is very easy for us to manually calculate this instead of doing using the 8086. So what will be the answer? 4 plus 1 it is 5, 3 plus 2 it is 5, 4 plus 2 it is 6, 5 plus 1 it is 6. So this answer we have to get in the 8086 also. So for that, so first we have to move or get the 16-bit data to the AX register. So what we are going to do means move AX comma. So instead of directly moving the data through the address location, I am going to move the data. That is, I am going to give one address location as 1100. So what is 1100? It is a address location. So where my 16-bit data will be there, 1100, 1101. So these two locations will be having the 16-bit data. So each memory location can carry only 8-bit data. So 1100 will have the least 2 digits, that is 3, 4. 1101 will have the next 2 digits, that is 1, 2, because this is one 8-bit data. So this 8-bit data will be stored in 1100. This 8-bit data will be stored in 1101. So first we are using the instruction move AX comma, within the bracket we have 1100, square bracket we have 1100, meaning that whatever it is there inside 1100 and 1101 location, that will be moved to AX. So now AX will be loaded with the data 1, 2, 3, 4, because whenever we give square bracket, meaning that it is address location. In this address location, whatever the data available, that will be moved to AX location. Then I am going to use the instruction called add AX comma 1102. So if I give like this, it will check your 1102 location and 1103 location. So 1102 location, if I give the value 21, 1102 location if I give the value 54, then these two datas, because this is again the address only we will give in the square bracket. So whatever the value located in the address 1102 and the next consequent address, that is 1103. So these two data will be added with the AX. Okay. So since I give add instruction, what it will do means AX data and then the data available in the address 1102 both will be added and then it will be moved to AX register. So AX data is what? 1, 2, 3, 4, and then 1102 location is having the data. What data it is having? 5421. Okay. So always this is least digit, LSB we will say, least significant byte. This is MSB, most significant byte. So similarly, this is least significant byte, this is most significant byte. So we have to write LSB first followed by MSB. So this is AX data, this is 1102 data. So these two data will be added, okay, both will be added and then it will be moved to AX. So what is the added value? 4 plus 1, 5, 3 plus 2, 5, 2 plus 4 it is 6, 5 plus 1 it is 6. This data only now it will be moved to AX register as per this instruction. Okay. So after this instruction AX value, after this instruction AX value will be 6655. Why? Because it will add AX with the data available in the 1102 1103, then again the result will be stored in AX. Then so suppose we need to store this result in some other location, okay, and also if there is a chance of getting carry, that carry also I have to store as a result, then I have to think about the carry. For example, here I don't have any carry value, right? So I don't have any carry from this digit, right? MSB, that is most significant bit, I don't get any carry. So here the carry is equal to 0, but there is some chance whenever I do some other addition of two numbers, then there is a chance to get a carry as 1. So in that case I have to store the carry also. So how we have to proceed the program? So let me write the program within this. Okay, so we have to consider about the carry. So we have one instruction called JNC. Let me consider the label as loop. JNC means jump on no carry to loop. Whenever there is no carry, jump on no carry. Whenever there is no carry, this will go to this label, right? Directly the 8086 will go to the next label whichever it is assigned. So since I have given loop, it will go to this place, it will not execute the other instruction whatever here. Okay, so jump on no carry, whenever there is no carry means it will go to this label and execute whatever the instruction available here. Suppose if there is a carry, then it will not go to this place, it will execute the next instruction. That is what we have to understood. So it is similar to your for loop or while loop. Some condition is satisfied, right? So some condition is satisfied, it will go to that location. If it is not satisfied, it will execute the next instruction. So jump on no carry. So here according to our content, right? So here there is no carry. So carry value is equal to 0. So whenever there is no carry, it will go to loop. So what happened? We have to store the result in some location. So what result I have? The result is there in the AX register. So move, I have to store in some location. So use square bracket here, as this is the destination, always the right hand side is the source. So let me have the address as 1200 for storing the result. Then AX. So we are storing the value AX into the memory address 1200. So what happened? Another memory location. In the another memory location, I am storing the answer of AX. AX is what? 55 followed by 66. So it will store 55 in 1200, 66 in 1201 location. And then again we have to consider about carry, right? So whenever there is no carry, we are going to consider the carry will be stored in the register CL. So let me assume one more register like CL. Move CL comma, let me consider or initialize the CL register. So CL register generally it is used for storing the count. So I am first initializing the CL with the immediate data 00. So what do you mean by immediate data 00? Means whatever the data 00, directly it will be stored in CL. So this instruction will make CL equal to 00. Okay. So for carry I am considering one register CL. In that CL, I am initializing the value as 00. So after this instruction execution, the carry will not change, CL will not change, the value will be 0 only. So that also I am going to store as a result. So for that I am going to use one more address, move 1203 comma CL. So what happens? CL value, that is 00, will be moved to 1203 location. So if you want, you can store in 1202 also. I am using 1203. So 1203, I am storing the CL value. So 1202, some other value will be there in the memory, will be there as it is. So 1203, I am storing the CL value. Then once it is over, I have to stop your program. So for that I have to use HLT, halt. Halt is nothing but it will stop the execution. And then, so this is the scenario whenever there is a no carry after your result. Suppose if there is a carry, then what happens to the CL? It becomes 1. So we have to make CL value as 1. So one more instruction we have to give here as INCCL. What do you mean by INCCL? Means increment CL. So CL value will be incremented to 1. Okay. So whenever there is no carry, AX value will be moved to 1200, CL value 00 will be moved to 1203. Suppose there is a carry, then it will not go to loop. What it will do? It will execute the next instruction. What is the next instruction? Increment CL. So increment CL means CL value will be incremented. Already 0, 0 plus 1 which is equal to 1 will be loaded in CL. So increment CL means 1 will be moved to CL. Then after this automatically the next instruction will be executed. Okay. Even though I am not giving any loop here, automatically the next instruction will be executed. What is next instruction? AX. AX value will be moved to 1200 and then CL incremented value will be moved to 1203 and then we have to stop your execution. Okay. Thank you. Thanks for watching.